if we take a look at cylinders that are a little bit more interesting, for example, take a look at this one. This is a cylinder that's no longer a right cylinder, but it has a little tilt to it. It kind of looks like the leaning Tower of Pisa. So maybe we should call this the leaning, I don't know, what do you want to call it? I'll just call it, I'll just say, look, here it is. There it is. There's a cylinder. It's the leaning cylinder of Pisa if you want, but if you don't like Italy, that's okay. All right, so the question is, what's the volume? Well, the volume we can actually find out even though it's sort of leaning. And we just use the exact same formula that we already know. It's the same concept. We find the area of the base and we multiply by the height. But now we're not going to multiply by this sort of funny height. We're going to multiply by the straight height right up there. And so we take the area of this and multiply by the height. You know the way that I think about this? Let me tell you how I think about this. Imagine this was like a whole bunch of, like a stack of bologna. Okay? Imagine it's a stack of bologna, and it was sort of tilted a little bit. If you were just to sort of take your hand and straighten it out, then you would make this thing completely straight, and then you would see that that height would be 10. So in fact, this sort of leaning thing is actually the same thing as a straight thing with that as its height. Philosophically, that's what's going on here, and so that's why this formula is going to hold. So how would we actually find the volume of this? It's just the area of the base times the straight up height. So the volume equals pi times r, so that's going to be 6 squared, which equals 36, times the height, which is 10. And so I see 360 pi. And what are my units? Well, they're centimeters, but it's volume, so it's centimeters cubed. Neat. All right, let's try another question, see if we can sort of put some of these ideas together with a slightly more exotic question. We want to find the volume of a cylinder with a base area of 25 pi inches squared and a height equal to the radius. Now, there are a lot of words here, and this sounds a little complicated. The first thing I would do is draw a picture. So let's draw a cylinder. Okay, so there's my cylinder. All right, I need to know the height. I need to know the radius. Let's see what I know. Well, I'm told that the base area is 25 pi inches squared. That's the area of the bottom circle. Let's take a look at a top view. It looks like a circle, has a certain radius, and we're told that the area of that circle, because that's what the base is equal to 25 pi. And we know that the area of a circle is pi r squared, so this is going to be r squared pi. And if we simplify that, I see that 25 equals r squared. Well, I can now figure out what the radius is. What's the radius? Well, mathematically, if you were to solve this, there are two answers. The radius would be plus or minus 5. But of course, radius is representing a length, and so I know immediately that in this context, r is just going to be 5. So the radius is 5. So we've just learned that our radius is 5. That's great news. What's my height? Well, the height is equal to the radius. Oh, great. Well, I just found the radius, so this height is also going to be 5. Now, you can see that my picture is not drawn to scale, but that's completely okay. The picture was there as a crutch to allow me to sort of understand the question. If I want to draw an accurate picture, I got to squash this down almost like a tuna fish can. All right, but anyway, we can still find the volume, because the volume is going to be what? It's going to be pi r squared h. That's going to be pi times r squared, that's 5 squared, times h, which is another 5. That's actually 5 cubed, or 125. So the volume is 125 pi, and what are my units? My units are now inches, but they're inches cubed because I'm talking about volume, 3 dimensions. So you can see here, it was a little tricky question because the information was hidden. We had to first of all think and find the radius. Once we found the radius, using the fact that we knew the area of the base, we were home free.